Okay, so today we're going to look at interpreting our equations in terms of the particles that interact. So this is going to be a review. We talked about this last week. And then we'll talk how that balanced equation ties into everything we've been doing with moles. So just as a reminder, okay, there are different kind of particles. Okay? If you have an element, the type of particle you're going to have is an atom. Well, usually, unless it's diatomic. Okay. You'd have molecules of something made up of just nonmetals. Okay. Carbon dioxide, the ones that we'd use prefixes when we were naming them. And then you also have molecules of the diatomics. And then the third type of piece, the one they don't mention until you get to chemistry, is the formula unit. And formula units are for ionic compounds. And you'll know it's an ionic compound because it'll have a metal and a non-metal in it. So all we have to know is what kind of piece it is to interpret it in terms of particles. So tonight's homework is going to have you pick the pieces. So, for example, if I want to interpret this equation in terms of molecules, there's a 2 there, and then it's H2. Well, H2 is a diatomic element, so H2 is a molecule. So that 2H2 could say 2 molecules of hydrogen. The plus sign means and, so and 1 molecule of oxygen. I'm just taking the coefficients to get the 2 and the 1, and it's going to form 2 molecules of water. So the pieces that are actually involved are 2 molecules of hydrogen, 1 molecule of oxygen, and you make 2 molecules of water. In terms of pictures, you have 2 little H's, 1 big O, and you're going to make 2 H2Os. Okay. This one was easy because everything was a molecule. Hydrogen was a molecule because it was diatomic. Oxygen was a molecule, it's diatomic. And water's a molecule because it's formed by covalent bonding. So let's try it with this decomposition reaction. Okay. 2Al2O3 makes 4 Als and 3 O2s. So if we want to interpret that in terms of particles, first I'm going to write the 2. And I got Al2O3. I have to decide what kind of piece it is. Since Al, aluminum, is a metal, that makes this ionic, so it's a formula unit. So we've got 2 formula units of Al2O3. That's going to make 4. You got to decide what kind of piece aluminum is. Aluminum is an element, and it's not diatomic, so the smallest piece of an element is an atom. So it's 4 atoms of aluminum. And the plus sign is and 3. Okay. O2 is an element, but it's diatomic. So instead of being an atom, it's a molecule. So if you look, all I did was insert what type of piece it is. 2 Al2O3, 4 Al, 3 O2. And all I did was insert what kind of piece it is. Let's try one more. Okay, single replacement reaction happens between sodium and water. Water gets treated as HOH, replaces one of them, makes NaOH and H2. And I've balanced the equation. So to interpret this in terms of particles, first I'm going to write 2. Then I have to decide what kind of piece is Na. Since Na is an element and it's not diatomic, it's an atom. So I can say 2 atoms of Na. And 2 H2O. We just talked about H2O a second ago. Since it's covalently bonded, the type of piece for H2O is going to be, it's going to be molecules of water. They form 2, let's go back, 2 NaOH. Look at that first element, Na is a metal, so that tells me this is ionic. And if it's ionic, it's got to be a formula unit. And 1, I know if there's no coefficient, there's a 1 there. What kind of piece is H2? Well, H2 is an element, but it's not by itself, it's diatomic. So that must make it a molecule of H2. So as you can see, this sentence and this equation say the same thing. So all we got to do is tell what kind of piece it is, and that's what the homework's going to ask you to do tonight. Okay, and now we're going to tie it to moles. So we got this equation, and we said that was 2 molecules of hydrogen and 1 molecule of oxygen makes 2 molecules of water. But what if I did this 12 times? Wouldn't 2 dozen molecules of hydrogen and 1 dozen molecules of oxygen form 2 dozen molecules of water? Yeah, if I do it a dozen times, I'll use 2 dozen molecules, and I'll make 2 dozen molecules. If I do it a bigger number of times, if I do it 1,000 times, then 2,000 molecules of hydrogen and 1,000 molecules of oxygen will form 2,000 molecules of water. If I did it a bigger number, 1,000,000 times, okay, then I could put 2,000,000 molecules of water and 1,000,000, so 2,000,000 molecules of hydrogen and 1,000,000 molecules of oxygen forms 2,000,000 molecules of water. Okay, but let's do it a lot of times. Let's do it Avogadro's number of times. So I did Avogadro's number of times. I just have to take 2 times Avogadro's number to talk about molecules of hydrogen, 1 times Avogadro's number of oxygen. So it's still just the coefficients times how many particles. But if I had 6.02 molecules of hydrogen, I'd have a mole of hydrogen. So the whole purpose of this was that we can write these equations in terms of moles. Okay? That if I do it a bunch of times, I can say 2 moles of hydrogen and 1 mole of oxygen make 2 moles of water. So the coefficients up here are the same as the coefficients on the bottom, and all I do is stick in the word mole. So let's try this one in terms of moles. Okay. We did in terms of particles before, but now the easy one. To interpret in terms of moles is easy because I can just say 2, and then I'm going to do it Avogadro's number of times, so I am going to have 2 moles of Al2O3 form 4 moles of Al and 3 moles O2. The whole idea here is the coefficient tells us how many kind of moles. That we can read these equations in moles. So reactions happen 1 atom at a time or 1 particle at a time, but we can't see those, so we're going to count groups of them at a time. So reactions happen moles at a time. Okay? So with that, you should be ready to do tonight's homework. The form's online. Go ahead and type those answers in. And have a great day.